In this video, we will be taking notes over 4.1, slope. Slope has a lot of meaning in mathematics. Calculus, which perhaps some of you will study after algebra, devotes much of its study to slope. For us in algebra, we'll have two main contexts for slope. One is the slant of a line. And by slant of a line, I'm talking about steepness. The other context we'll describe slope is as a rate of change. The rate of change between two variables, and we'll just use the arbitrary x and y. Slope is the rate of change. It is the change in y divided by the change in x. And this little symbol right here, this triangle, it's the Greek letter delta, capital delta, and it represents, in math, we consider it change in. All right, well, what is change? It's a subtraction. You're buying something that costs $2, you pay a $5 bill, you get $3 change. So when I say change in y, I'm saying simply to subtract some y's. I'll call it y2 and y1. And change in x will be x2 minus x1. This is often referred to as the slope formula. And we use m to represent slope. Slope, we use m in math. Slope is m. So this formula over here, that is how we find, one of the ways we find m. Okay, so let's look at it in terms of slant of a line. Slant of line. This graphic here is from your digital text. You can look at it in your ebook, but you'll probably be fairly familiar with this. If the line is, we're talking about from left to right, if the line is moving down, we say that it has negative slope. If the line is horizontal, we say that the slope is 0. If the line is moving up, we say that it's positive slope. This makes sense to me. 0 is the number between the negatives and the positives, and this line is in between those two lines in terms of its slope. One last slope that we talk about is no slope or undefined. If the line is vertical, so draw yourself one more x and y axis, and now I'm going to draw a vertical line. If the line is vertical, here we say no slope, not 0, but no slope, or undefined. And we will see why using the slope formula shortly. Okay. How will we calculate slope? How will we calculate slope? Okay. First thing we need is 2 points. We're dealing with straight lines, and straight lines are defined by 2 points. Okay. Once we get those 2 points, we can use one of these two methods. Method 1, slope formula, and that's what we just saw. The slope formula will be m equals change in y divided by change in x, and that is y2 minus y1 divided by x2 minus x1. That is method number 1. All right. Method number 2. Rise over run. This really is capitalizing on this same change in y, change in x. So we can say that the slope of a line is equal to the rise over the run. And this rise is either up or down, depending on the sign. And this run we'll consider to the right, like we read from left to right. Okay, we're going to count how many units that it may be, and we'll look at an example that employs both of these methods. All right. So now I'm going to our XYZ homework. All right. Question number 1 says, find the slope of the line through the points 5, 2, 3, 1, and then graph the line. Well, I'm going to show both methods using this particular point. So going back to our notes now, we have the points 5, 2, and 3, 1. So, using our first method, the slope formula. Okay, we have the points 5, 2, and 3, 1. I'm going to use this slope formula. So, m equals y2 minus y1 over x2 minus x1. Well, this y2 and y1, it doesn't they're just referencing the y coordinates. It doesn't matter which one we call y2 and y1, provided we do the same with the x's. So for y2 minus y1, I'm simply going to subtract 2 minus 1. In the numerator, I have 2 minus 1. The denominator shows x2 minus x1. Since I went 2 minus 1, I'll need to go 5 minus 3. 2 minus 1 is 1. 2 minus 1 is 1. And 5 minus 3, that is 2. So my slope is 1/2. All right, let's look at this same problem using the rise over run situation. So I'm coming back to XYZ. It says plot these 2 points. Graph this line. I'm clicking on the line. I'm going to graph 5, 2, 5 pairs with 2, and 3 pairs with 1. All right, there's my line. Now I'm going to show the rise over run method. All you have to do is take 2 points. Any 2 points will do. And then draw yourself a right triangle between those 2 points. So I'm using these 2 points. I'm going to construct a right triangle between these 2. Okay? The rise is how much we move up. In this case, we're moving up 1. All right? I'm just going to indicate plus 1 to show that it is indeed positive. The run, we will always consider it positive. We'll counting to the right. Here, I notice I move 1, 2 units to the right. Okay, so this one is my rise. It's how much I went up. This right movement is my run. So I have my rise over my run. In this case, slope is, the rise is 1, and the run is 2. So again, I see that my slope is 1/2. It jives with my using of the slope formula. And you can see this rise over run is really the same as the slope formula. Here we're saying a change in y. Well, a change in y, that is a vertical movement. We went from 1 to 2 in the y's. It was an increase of 1. The run is a change in x. Well, a change in x is a movement to the right. Here we went from 3, an x value, 5x value. That was a change of 2. So really this rise over run and the slope formula are very similar. Let's return to XYZ and look at perhaps one or two more examples. So we see this one, our slope is 1/2. All right, this one is throwing a little more algebra in it. Instead of giving us points that are strictly constants, now we've included this algebraic expression of 4x and 2y. So let's see how we can handle this. One point's 4x comma 2y, the other point's 5x 4y. All right. Slope equals y2 minus y1 divided by x2 minus x1. In this case, our y's are 2y and 4y. Again, it doesn't matter which order that I put these. I'm just going to do the, in this case, 4y minus 2y. 4y minus 2y. My x's, since I subtracted 4y minus 2y, I must subtract 5x minus 4x. So my denominator is 5x minus 4x. Well, equals 4y minus 2y, that's 2y. 5x minus 4x, that's 1x. And 2 divided by 1, that's 2, so I could simply leave this as 2y over x. In this case, our slope is 2 y units per every 1 x unit. More examples and one more note that we need to add. Solve for A if the line through the two given points has the given slope. We want to solve for this A in this case. Again, we will utilize our slope formula. Slope equals change in y divided by change in x. I'm going to subtract negative 4a minus negative 3a. Negative 4a minus negative 3a. Change in x. Since I subtracted negative 4a minus negative 3a, I'll have to subtract 5 minus 3. All right, now with this time we know the slope. The slope is to be 1, so I can set this expression equal to 1. All right, doing some simplifying. Negative 4a minus negative 3a, this becomes plus, so in the numerator we have a negative 1a. All right, 5 minus 3, that's 2. Okay, but we still have the 1 on this side. I'm simply going to write it over here. Slope is 1, and we have this expression. So now I just need to solve for a. Well, if you want to eliminate a fraction, all you need to do is multiply by that denominator. All right, so I'm going to multiply this entire equation by 2, multiplying by 2 on the right and left. 1 times 2 is 2, and this 2 divides with this 2 to leave a negative 1a. Solving for a, I'll divide by negative 1 on both sides. So a is negative 2. Okay. This question says complete the table then use to find the slope of the graph of the equation. Well, here we're using a method we used before, the x and y intercept method. All you have to do is substitute 0 in place of x and solve for y. Substitute 0 in place of y and solve for x. Then you'll have 2 points and you can use the formula we've just considered. Question 5 says find the slope of any line parallel to the line through. Okay. Question 6 asks similar, find the slope of any line perpendicular to the line through. Well, let's go back to our notes. I want to add two more notes. parallel, and perpendicular. Parallel and perpendicular. Parallel, the symbol for parallel in math is two lines side by side. This is the symbol for parallel. The symbol for perpendicular is an upside down T. Parallel, perpendicular. Parallel lines have equal slopes. So if they're asking you to find the slope of a parallel line, you simply find the slope of that line, and it'll be the same. Parallel lines have equal slopes. Perpendicular lines have negative reciprocal slopes. For example, an example of negative reciprocal. Negative reciprocal. If one of the lines, I'm going to say if slope 1 is 3 over 2, then the slope of a line that's perpendicular to that number 1, is going to flip this number over, 2 over 3, and make it negative. Negative reciprocal means flipped and changed. Okay, these two are negative reciprocals. Negative reciprocal. All right. Another example. If one line had a slope of 4, the slope of a perpendicular line to that one, to number 2 here, well, 4 is like 4 over 1, isn't it? So flipping over 4 over 1, we get 1 over 4, and it would be negative. Again, these two are negative reciprocal. Negative reciprocal. It's a flipped and changed fraction. All right, that concludes these notes.